All right. Descartes' rule of signs. I think I am going to turn on that other light. Okay. Descartes' rule of signs says that given a polynomial f of x, the number of possible positive real zeros or roots is the number of sign changes in f of x, or 2 fewer, 4 fewer, 6 fewer, etc. Okay. The number of possible negative real zeros, negative, is the number of sign changes in f of negative x, or 2 fewer, 4 fewer, 6 fewer, etc. Some facts that are helpful for this aspect. Negative x to an odd power would give you negative x to the odd power without the parentheses. Negative x to an even power would just give you x to the even power. It would always be positive. Okay? So any negative number to an even power gives you positives. All right. The rational root theorem, or rational zero theorem, says given polynomial f of x where you have a times x to some power on down to a constant, the possible rational roots are plus or minus p over q, where p is the factors of the constant c, and q is all the factors of the lead coefficient a. All right? And I have gone ahead and put up an example. Okay? We're going to be finding the number of possible rational roots. So, possible, positive, real roots, or zeros. That's positive 11x to the 7th, switching, and then negative 23x to the 6th. So that's a positive term. That's a negative term. This represents a sign change. So sign change number 1. Sign change number 1. That's sign change number 1, from a negative to a positive. That's negative to negative, so that's not a sign change. That's negative to positive. Number 2. That's positive to positive, no change. Positive to positive, no change. Positive to positive, no change. Positive to negative, that's number 3. So there are either 3 or 1 positive real roots. So 3 or 2 fewer. Possible negative real roots. That's going to be f of negative x is equivalent to 11, negative x to the 7th, minus 23, negative x to the 6th, minus 64, negative x to the 5th, plus 72, negative x to the 4th, plus 49 times negative x to the 3rd, plus 83 times negative x squared, plus 124 times negative x, minus 12. Okay? So let's simplify that using these rules. So this one is negative x to the 7th. So negative x to an odd power would give you 11 times negative x to the 7th, because that's an odd power. Minus 23 x to the 6th, because that's an even power. Okay? This is going to be minus 64 times negative x to the 5th, because it's an odd power, will be negative, plus 72, that's an even power, so it'll just be x to the 4th. That's going to be plus 49, and that's going to be negative x cubed, because it's an odd power. This will be 83. That's got to be x squared because it's an even power. This is got to be minus 124x minus 12. And then I'm going to simplify these as well. So this will give me negative 11x to the 7th minus 23x to the 6th plus 64x to the 5th plus 72x to the 4th minus 49x cubed plus 83x squared minus 124x minus 12. So now we count the sign changes. That's negative to negative, so that's no change. You write that more leisurely. So that's negative to negative, no change. Negative to positive. Sign change number 1. So negative to negative, no change. Negative to positive, that's the first change. Positive to positive, no change. Positive to negative, that's a sign change. So number 2, from negative to positive, that's a change. Okay, that's positive to negative, that's a change. Negative to negative is no change. So there will be 4, or there's 4 sign changes. So that would be 4 or 2 or 0 negative real roots. Okay? Now, we're not just going to talk about the rule of sign, the signs. We're going to actually solve this using the rational root theorem. So we're going to solve this problem. And then once we solved it, we're going to come back and confirm that we're going to confirm the solutions with this list. Okay? So give me a moment. I'm going to move this over to the other part of the board. All right. So I went ahead and recopied the problem. Now, you guys cannot see the rational zero theorem, so let me go ahead and turn this back over so that you can see it, and then we'll twist this back over. So here's what we have. P, so to find the roots of this 7th degree polynomial, it's equivalent to finding the polynomial equation equals 0. So P is all the factors of the constant C. So we're going to find all the factors of 12, negative 12. Okay? So that will be, so P will be plus or minus, because these are factors of 12. Okay? 12, negative 12, negative 12. So that would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Those are the factors of 12. Q is all my factors of the lead coefficient 11. Okay? So the factors of 11 are plus or minus 1, plus or minus 11. Those are my factors of 11. So plus or minus P over Q is equivalent to all these over 1 and all these over 11. Well, putting all of these over 1 would just leave you all the P's. 1 divided by 1 is 1, 2 divided by 2 is 2, 3 divided by 1 is 1, 3 divided by 1 is 3, 4 divided by 1 would leave you 4, and so on. The only other roots would be 1 over the 11, 2 over the 11, plus and minus, 3 over 11, 4 over 11, 6 over 11, and 12 over 11. Those are potential rational roots. That doesn't account for the irrational roots, but it does account for the possible rational roots. So I recommend starting with the p's. Try x equals 1. Because remember, under synthetic substitution, we want 0. Okay? I want 0. So we'll have 1 in the box, and we're going to have 11, negative 23, negative 64. Let me go ahead and mark this off. So 11, negative 23, negative 64, 72, 49, 83, 124, and negative 12. Plus, empty row, and I want 0. So bring down the 11. 1 times 11 is 11. That gives me negative 12. 1 times negative 12 is negative 12. That gives me negative 76. 1 times negative 76 is negative 76. That's negative 4 when you add them up. 1 times negative 4 is negative 4. That's 45. 1 times 45 is 45. That's 128. 1 times 128 is 128. That's going to be 252. 1 times 252 will be 252. That's 240, which is not 0. So x does not equal 1. Next, we'll try negative 1. So I'll have negative 1 in the box. 11, negative 23, negative 64, 72, 49, 83, 124, and negative 12. I'm going to have to move this down. I'm not starting the problem over. Okay? Okay, so negative 1 will go in the box. We'll have 11. Negative 23. Move it over. 11, negative 23, negative 64, 72, 49, 83, 124, and negative 12. All right, so bring down this 11. Negative 1 times 11 is negative 11. That's negative 34. Negative 1 times negative 34 is positive 34. That gives me negative 30. Negative 1 times negative 30 is positive 30. That's 102. Negative 1 times 102 is negative 102. Okay, I'm going to grab a calculator for that. 49 minus 102. Negative 53. Negative 1 times negative 53 is positive 53. 136. Negative 1 times 136 is negative 136. And somewhere along the way I have made a mistake because I know what the answer is supposed to be. All right, so 11, negative 34, positive 34. Oh, that's negative 12, of course. Okay, and negative 1 times negative 12 is positive 12. That's 0. Okay, so x equals negative 1 is a necessary aspect of that. Now, because this process also doubles the synthetic division, we have 11x to the 6th. Minus 34x to the 5th, minus 30x to the 4th, plus 102 x cubed minus 53x squared plus 136x minus 12 equals 0. We're now going to solve that next. We'll try x equals negative 1 again, because it could work in this equation as well. Okay, again. So I'll have negative 1 in the box. I'm going to use this one, 11, negative 34, negative 30, 102, negative 53, 136, and negative 12. All right, so I'll bring down this 11. Negative 1 times 11 is negative 11. That's negative 45. Negative 1 times negative 45 is positive 45. That's 15. Negative 1 times 15 is negative 15. That is 87. Negative 1 times 87 is negative 87. That's negative 140. Okay. Negative 1 times negative 140 is positive 140. That's 276. Negative 1 times 276 is negative 276. This is negative 288, which is not 0. Okay, so not this time. But it's still a root of the original equation. So we're going to keep it listed at the end. All right, so now it's time to turn this so that we can continue the problem. And hopefully we can see the whole thing. Looks like you can. Okay. It's hard to see on my monitor. I apologize. Okay? So we're still working on 11x to the 6th minus 34x to the 5th minus 30x to the 4th plus 102x cubed minus 53x squared plus 136 minus 12 equals 0. Okay, that's what we're working on. Okay, so once a root doesn't give us 0, we no longer consider it. So 1 never gave us a 0. Negative 1 did once, but it doesn't do it. It stopped doing it. So now we'll move on to 1 didn't work, negative 1 didn't work. Now we'll do 2. So 11, negative 34, negative 30, 102, negative 53, 136, and negative 12. I'm looking for 0. So that's not this time. Okay. All right, so we'll bring down this. So this is 11. Bring down the 11. 2 times 11 is 22. That's negative 12. 2 times negative 12 is negative 24. That's negative 54. 2 times negative 54 is negative 108. That's negative 6. 2 times negative 6 is negative 12. That's negative 65. 2 times negative 65 is negative 130. That's 6. 2 times 6 is 12. That's 0. So x equals 2. Okay? Third, that's a division result. So we will have 11x to the 5th minus 12x to the 4th minus 54 x cubed minus 6x squared minus 65x plus 6 equals 0. Okay? Now, now we consider the factors of 6. So we'll reconsider. Now the constant has changed, we're going to reconsider the P's and Q's again. So P will be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. 11 is still 11, so Q is plus or minus 1, plus or minus 11. So plus or minus P over Q equals all the P's and all P's over 11. But x equals 1, negative 1 are out because they stopped giving. This one never gave us 0. Negative 1 gave us 0 once and then didn't do it again. Okay? So we'll try 2 again, because 2 may work in the new polynomial. So we have 11, we have 2 at negative 12, we have negative 54, negative 6, negative 65, and 6. So we bring down the 11. 2 times 11 is 22. That's 10. 2 times 10 is 20. That's negative 34. 2 times negative 34 is negative 68, pardon me. That's negative 74. 2 times negative 74 is negative 148. All right, I'm going to get my calculator out for that one. Negative 65 minus 148 is negative 213. And that's going to be negative, when we multiply it by 2, we're going to get negative 426, which gives us negative 420, which is not 0. So not this time. So 1 and negative 1 are out. 2 stopped giving us 0, so now we'll try negative 2. Okay, so we have 11, negative 12, negative 54, negative 6, negative 65, and 6. All right, bring down the 11. Negative 2 times 11 is negative 22. That gives me negative 34. Negative 2 times negative 34 is positive 68. That gives me 14. Negative 2 times 14 is negative 28. That's negative 34 again. That's negative 2 times negative 34 is positive 68. That's 3. Negative 2 times 3 is negative 6. That's 0. So x equals negative 2 as well. Okay? All right, so that's going to give me also 11 x to the 4th, because it's a division result, minus 34x cubed plus 14x squared minus 34x plus 3 equals 0. Now, this has all powers of x, so any previous methods we covered involving u equals x first substitutions, that would not work here because we have odd powers of x. If you don't remember that method, don't worry about it. So we're going to revisit the p's and q's because the constant has changed. So it's the factors of 3 are plus or minus 1, plus or minus 3. Q, 1, and 11. So plus or minus p over q is the p's, all current p's, okay, and all the p's over 11. Okay, so we're not going to try negative 2 again because it's not on the list. Okay, also 1 and negative 1 are now out. Okay, 1 never gave us 0. Negative 1 gave us 0 once and never did it again. So 1, negative 1 are out. We're not going to try negative 2 again because it's not a factor of 3. So 1's out, negative 1's out. 3 is the next candidate. So we have 11, negative 34, 14, negative 34, and 3. Okay? We have 11. 3 times 11 is 33. That's negative 1. 3 times negative 1 is negative 3. That's 11. 3 times 11 is 33. That's negative 1. 3 times negative 1 is negative 3. That's 0. We also have 11x cubed, because it was x before, now it's x cubed, minus x squared plus 11x minus 1 equals 0. We're now going to finish that problem over here. So we have 11x cubed minus x squared plus 11x minus 1 equals 0. This is factorable by grouping. I could take an x squared out of this, I'd get 11x minus 1. Okay? And I could factor a 1 out of this. Well, we'll watch this. Okay? It is factorable by grouping. This is 1/11 of this. This is 1/11 of that. Okay? This is 1/11 of this. This is 1/11 of this, and opposite signs. That's how we know. Okay? So I'll take an x squared out of this term, these two terms. That leaves me 11x minus 1. I can factor a 1 out of these two terms. That gives me 11x minus 1 equals 0. So, this gives me x squared plus 1 and 11x minus 1 equals 0. That's not factorable. So we're going to have to use a square root property. This is going to be x squared plus 1 equals 0. This is 11x minus 1 equals 0. So we'll subtract 1, and x squared equals negative 1. So x itself equals plus or minus the square root of negative 1 in algebra. So x equals plus or minus the square root of negative 1 is I. This one we add 11, or add 1, 11x equals 1. Divide off the 11, and x equals 1/11. So the zeros. All zeros. All the zeros. From least to greatest, they are negative 2, negative 1, let's see, 1 wasn't on the 1/11th would be on the list. Okay, we'll start with the real zeros. 2 and 3, okay? 2 and 3. And negative I, positive I. 1, 2, 3, 4, 5, 6, 7. It was a seventh power equation. We got 7 solutions. Okay? Now, there were, going back to the Descartes rule of signs, there were 2 negative real roots. Okay? These 2. There were 3 positive real roots. and there were two imaginary, or two non-real roots. We'll call them non-real. Two non-real roots. Okay? So, when we did the Descartes rule of signs, we determined that there was one sign change, two sign changes, three sign changes. That would have given us 3 or 1 positive real roots, which is what we had. Okay? Let me twist this back over and see if we might be able to fit the whole thing in. No, it's hopeless. Give me a moment while I push this back. All right. Yeah, it's hopeless. Okay, so let me zoom back over where we did Descartes' rule of signs. I'll just move this back over and move it back closer again. When we did Descartes' rule of signs, we counted the number of sign changes. So positive to negative, that was 1. And then negative to positive, that was 2. And then positive to negative, that was 3. And we determined that we should have 3 or 1 positive real roots. When we did negative real roots, that meant you had to plug in x and negative x. Okay? Negative x to an odd power left you negative x to that power. Negative x to an even power left you positive x to that power. So take a good look at it. When it was cleaned up, we determined that there was 1, 2, 3, 4 sign changes. That would have given us 4 or 2 or 0 positive roots. Or negative real roots, sorry. All right. And as we go back to the original, to our solutions, we indeed had 2 negative real roots, 3 positive real roots, and we had 2 non-real roots. Descartes' rule of signs doesn't tell you how many non-real roots you will have. But that is exactly what Descartes' rule of signs predicted. And that's where I'm going to stop here.